Data splitting. Training set and test set. Dr. Gudipati Srinivasa Rao. Introduction. Artificial intelligence models learn patterns from historical data to make predictions or decisions. However, to evaluate whether the model performs well, the available data must be divided into separate subsets. This process is known as data splitting. Data splitting ensures that AI models are trained properly and tested fairly before being deployed in real business environments. In commerce and management, improper data splitting may lead to incorrect financial forecasts, faulty credit decisions, or inaccurate customer predictions. 2. What is data splitting? Data splitting is the process of dividing a dataset into two or more subsets for the purpose of training and evaluating machine learning models. The two primary subsets are 1. Training set, 2. Test set, 3. Training set is the portion of data used to train the AI model. Purpose: helps the model learn patterns, identifies relationships between input and output, adjusts internal parameters of the model. Typical size: 70% to 80% of total dataset. Example in commerce. In sales forecasting, past sales data from 2018 to 2023 may be used as training data. The model learns seasonal patterns, demand trends, and growth rates. In credit scoring, historical loan records are used to train a model to predict default risk. 4. Test set. The test set is used to evaluate the performance of the trained model. Purpose: measures how well the model performs on unseen data, evaluates accuracy, precision, recall, etc. Detects overfitting. Typical size: 20% to 30% of total dataset. Example in commerce. In customer churn prediction, the model is trained on past customer data. It is tested on new customer data to check if it correctly predicts churn behavior. The test set must remain unseen during training to ensure unbiased evaluation. 5. Why data splitting is important in commerce and management. 5.1 Prevents overfitting. Overfitting occurs when a model memorizes training data instead of learning general patterns. If a model performs well on training data but poorly on test data, it is overfitted. In business terms, a model may predict past sales accurately but fail to forecast future sales correctly. 5.2 Ensures model generalization. Generalization refers to the ability of a model to perform well on new, unseen data. In finance and marketing, models must generalize well to new customers and future transactions. 5.3 Improves reliability of decisions. Management decisions such as credit approval, investment planning, demand forecasting, risk assessment depend on models that are properly validated using test data. 6. Common data splitting ratios. Training set, test set. Usage scenario: 70% 30% standard practice, 80% 20% large datasets, 75% 25% balanced approach. The ratio depends on dataset size, business complexity, model type. 7. Special consideration: time series data. In commerce and finance, many datasets are time-based. Examples: stock prices, sales trends, economic indicators. For time series data, training set equals past historical data, test set equals recent or future period. Example: train model on sales from 2018 to 2022. Test model on sales from 2023. Random splitting is not suitable for time-dependent data. 8. Evaluation after data splitting. After splitting: 1. Train the model on the training set. 2. Test it using the test set. 3. Measure performance using metrics such as O accuracy, O precision, O recall, O F1 score, O mean squared error, MSE. Business managers should interpret these metrics carefully before deploying AI systems. 9. Risks of improper data splitting. Improper splitting can lead to data leakage, test data accidentally used in training, biased predictions, poor financial decisions, regulatory risks, loss of customer trust in banking and insurance. Incorrect model validation can cause serious financial consequences. 10. Practical illustration in commerce. Consider an e-commerce company. Step 1. Collect 10,000 customer purchase records. Step 2. Split data. 8,000 records. Training set. 2000 records test set step 3, train model to predict future purchases step 4, evaluate model accuracy using test data step 5, deploy model for personalized marketing outcome, improved sales, targeted promotions, better customer retention. 11. Strategic importance for management professionals. Managers must understand the logic behind data splitting, risks of overfitting, importance of unbiased evaluation. How model validation affects decision making. AI is not just technical, it directly influences strategic business outcomes. 12. Conclusion. Data splitting is a fundamental step in AI model development. By dividing data into training and test sets, organizations ensure that AI systems are reliable, accurate, and capable of making sound business predictions. In commerce and management, proper data splitting ensures trustworthy AI-driven decision-making. A well-validated model leads to checkmark better forecasting, checkmark reduced financial risk, checkmark improved operational efficiency, checkmark sustainable competitive advantage.